Hi there. Today we're going over 3.2, the algebra of functions. Today we'll be talking about problem number 5 and problem number 6. In problem number 5, we want to figure out the corresponding output value by using a table. So a couple of hints for you here. Make sure that you find the correct function. This says f. This column represents f. So maybe just go through, if you have a highlighter, coordinate that in your mind so you know where you're looking for the f function. And then the other piece says G. So here's G, here's G, here's G, 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 and you know you're looking in this portion of the table. So that's just a little hint to get started. Look in the right spot. The next hint is look at the X value. This is f of 9. So when you try to find the input, look in the X column, okay? All right, let's do it. What is f of 9? So I start with this portion of the table, and I'm finding f of 9. So the input value is 9. And what's the corresponding output value? 2. What is g of 18? I go to g. The input is 18. The corresponding output, 88. What is f of 29? F of 29 is 36 plus G of 14, so G of 14, 70. What's 36 plus 70? 106. G of negative 8, so G of negative 8 is 41 minus F of negative 4, so F of negative 4 is 43. What's 41 minus 43? Negative 2. F of 13, so F of 13 is 1 times G of negative 8. So G of negative 8, which is 41. 1 times 41 is 41. So you can see it's not that crazy unless you don't know what table you're looking at and what part you're looking at. So a little highlighting might be helpful, or just try to organize that in your mind. Let's do the last one. G of 14. So I look at G and the input is 14. The corresponding output is 70. So 70. And then F of 9. So I look at the F. The input is 9. The output is 2. So what is 70 divided by 2? 35. Let's look at problem number 6. Can we find the domain from an equation? This is a great hint over here. When you're thinking about the domain, you're thinking about all the possible input values where the function will exist. What can I input for x and keep the statement true? Well, let's look for exceptions. There are basically 2 exceptions in this course. You cannot divide by 0. So anytime you have a denominator, we know that we cannot divide by 0. We also know that when we have square roots, we can't take the square root of a negative. Actually, we can. It's an imaginary number. But when we're asking for the domain of a function, we are asking in the set of real numbers. So anything under the square root, we want to be in the set of reals greater than or equal to 0. Be careful when you do your homework and your tests. If I'm multiplying this by 3 or adding 4 on the outside, I don't care. It's only what's underneath the square root that you set greater than or equal to 0. That's the only part that will affect the domain. And this is a great way to remember. Okay, let's try it. What is the domain? Find the domain of f of x equals negative 5x plus 4. What can I plug in to x to make this statement true? Let's find the domain in interval notation. I can plug in anything in the set of reals. So I can go from negative infinity to infinity. That's your domain for f of x. What about h of x? What can I plug in to keep the statement true? Well, I know that the denominator cannot be equal to 0. And I see here that if it was 2 or negative 2, those two values would make the denominator 0. So I know that it cannot be 2 or negative 2. A lot of students have a hard time writing this in interval notation. So if you need to, just draw yourself a number line. I know that I cannot have a value of negative 2 or 2. Everything else I can input and the function will stay true. So as you see clearly in this picture, you have three intervals to state in your interval notation. This kind of helps students. Oh, yeah, a lot of my students try to only put two intervals like negative infinity to negative 2, union 2 to infinity, but they forget this interval in the middle. So don't let that be you. Notice this side is negative infinity, this side goes to infinity, and as you look at your picture, you can state the domain in interval notation. I can input from negative infinity to negative 2. Union, I can also input anything between negative 2 or 2. Union, I can also input anything from 2 to infinity. And there you have your domain in interval notation. Let's look at letter C. What about g of x? Well, whatever's under the root, so negative x minus 2, has got to be greater than or equal to 0. The square root of 0 is 0, so you're fine. So I add 2 to both sides, so negative x is greater than or equal to 2, and then I divide. Remember, when you divide by a negative, you flip your sign. So don't forget to do that. So there's a couple little tricks to look for. Okay, so this would be x is less than or equal to negative 2. And you can test it if you want. If I plug in a number less than negative 2, like negative 100, then this would give me 100 minus 2, which is a positive value. So we change the sign to keep the statements true. Now, how do I state this in interval notation? You can draw a picture or you can just state what's going to be less than or equal to negative 2. So the domain in interval notation would be from negative infinity all the way up to negative 2 because you're going less than or equal to. So don't forget your brackets. There's the domain stated in interval notation for A, B, and C. See you next time.